Hey everybody, this is Mr. Longo, and in this video we are going to cover quadratic models, and this is something that we're going to use our graphing calculators for, so if you don't have yours, grab it. So what we're going to do is start off by talking about a rectangle that has a perimeter of 3,000 feet. Now, some old formulas you need to remember is that the perimeter is 2 times the length plus 2 widths, and the area is length times width. Now, on a graphing calculator, however, we're going to need x's and y's. And another thing you must keep in mind is your graphing calculator can only really work with 2 variables at a time, x and y, not 3. So if you look at expressing the area as a function of w, that means we want our area formula to only have the letter w in it. Because otherwise you're going to have an a, an x, and a y, and your graphing calculator can't handle 3. So how do we do something like that? Well, the first thing we know for a fact is the perimeter is 3,000. So we can set our perimeter formula 2L plus 2W equal to 3,000. Now, since we want our area formula to only have a W, we need to somehow turn L into a W. And to do that, all you have to do is solve for L over here. So the first thing you want to do is subtract 2W from both sides. So you have 2L is equal to 3,000 minus 2W. Divide everything by 2, and you now know that L is equal to 1,500 minus W after you divide both sides, or both terms, by 2. So now that you know what L is equal to, you can substitute that into the area formula. So area is equal to length times width. So now we can say that the area is equal to the length, which would be 1,500 minus W times W. And now you would just distribute the W, and your area formula in terms of width only would be 1,500 W minus W squared. And yes, of course, if you did it the other way around and you have a negative W squared plus 1,500 W, it's going to be just fine. But the reason we're using this for the graphing calculator is because it's going to help us find the maximum area and what the dimensions of the rectangle need to be to do something like that. Okay? So, there are ways you can do this by hand. Now that you know the formula, you can just go find the maximum by completing the square and putting it in vertex form, or using the little shortcut formula. But it's very nice to know that your graphing calculator can do a lot of this for you. So, I have already typed it into Y1 just to save time on this video, but all you need to do is type 1,500x minus x squared, or if you did negative x squared plus 1,500x, that's going to be absolutely fine as well. And of course, this is going to have a massive area. If you think about it, if you had 1,500 as one of the lengths, it's going to be pretty big. So for my window, I am going to go with an x max of 1,500. I picked that because it's half of 3,000, in case you had just a length of 1,500 and a height of basically 0. And the maximum, I just went with something like 700,000. I know it's going to be really big, and we're going to find out right now. So once you click graph, you've got a parabola. And how do we find the dimensions that will give us the maximum area, and what is the maximum area? All you have to do is use your graphing calculator to go find a maximum. Now again, you could do this by just finding the vertex in a number of ways algebraically. Or you can press second trace and go to number 4, which is maximum. And when your calculator is asking you for a left bound, it means go to the left of the maximum a little bit and click enter. Now the calculator is asking for a right bound. That means you're going to go a little bit to the right of the graphing calculator and click enter. And then you're going to go to where it says guess. You just have to get close to the top, click enter again. And it's at 750, 562,500. So what are the dimensions going to be? Well, it told you that the width has to be 750. 750 times 750 is going to be your length times width, because remember, you have 3,000 feet. So that would be 750 plus 750 plus 750 plus 750. Okay? So, final answers is the dimensions is the length and the width are both equal to 750. Now, you might have guessed that in the first place because any rectangle that has the largest area is going to be a square. What is the maximum area? The area is 562,500 square feet. Okay? So that's how we use our graphing calculator to find maximums. The next example is just interpreting a function. Now, this one is going to be very easy to do with our graphing calculator. The equation was given to you. Now, I'm going to tell you the window for this one just to save you some time. Do an x maximum. Do an x max of, let's say, 350 should work. And try a y maximum of, I don't know, I'm going to say 100 because this is just being shot out at a 45-degree angle. I don't think it's going to get any higher than 100, but go ahead and try that first. But what I would like you to do is pause the video and see if you can handle this problem on your own. Go give it a shot. Okay, so in our graphing calculator, what you should have done is typed it into Y1, use the window I said. Now, what is the maximum height and what is the horizontal distance where the maximum height occurs? Well, you just have to find the max like we did in the last example. So we're going to just skip to that one and say that the horizontal, or what is the maximum height? The maximum height is 78.125 feet. And the horizontal distance was at 156.25. Remember, your horizontal is x, your height is y. How far does it travel before it hits the ground? So that one, what you would have needed to do is gone and found this intersection over here. So to do that, you could just go to y2 and type in a 0. And when you click the graph, you would just need to find the intersection. So to do that, you would click Second, Calc, number 5, Intersect. And all you have to do is get your little spider guy, or your little blinky, whatever you want to call it, closer to that side and click Enter 3 times. And it's going to give you 312.5. And the last question says, what is the height after it travels 215 feet? So to do that, that's telling you that x is 215 feet. So again, you can go look at second table, and this is set up where you have a table where you're asking for the graphing calculator to give you a value. The other way is just to, scroll through the table however you want to do. But anyway, this one we're going to say 215. Click Enter, and we're at 67.08. All right, so the answers to our last two questions were 312.5 feet, because that's where we found when the graphing calculator hit the x-axis. And how far, or what's the height after it travels 215? It was 67.08 feet. Okay? That's how we use our calculator to answer some quadratic questions. That's it for this one. This is Longo, and I'm out. See you, bye.